For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. When everything is exotic and strange, the familiar beckons. And when it comes to exploring the solar system, the familiar calls us to Mars. Although it is clearly an alien world, Mars is also a planet with landforms we immediately recognize. It is a world with deserts and dunes, cliffs and canyons, a landscape we can imagine ourselves exploring firsthand, on 2 feet or on 6 wheels. But familiarity doesn't make Mars any easier to understand. After scrutinizing its landforms from orbit and sampling its soil and rocks from the surface, we have become better acquainted with Mars than any other planet in the solar system apart from our own. But our questions about its present state and complex history have only multiplied, including the biggest question of all: did life ever exist here? Mars is not like Earth, where life is abundant and obvious. It's also not like the Moon, where there's really no chance for life at all. Mars is somewhere in between, and so it can help us define where life can and cannot exist. When we journey to Mars, we journey to the borderland. Mars's borderland status is nothing new. Astronomers have been musing about the potential for life on the red planet for more than a century. When the first grainy close-ups of Mars were radioed back in 1965, scientists were surprised and a little disappointed. The images showed a barren and cratered surface, much more like the Moon than any place on Earth. Apparently, the red planet was the dead planet, and any notion of spotting life on the surface, even primitive life, all but vaporized. But first impressions can be deceiving. As follow-up missions arrived in the late 60s and 70s with increasingly better cameras, it became clear Mars is a far more interesting and diverse planet than anyone had realized. Yes, there were impact craters, but there were also signs of a colossal geologic history. Giant volcanoes, larger than any on Earth, were found towering over the Martian plains. The largest of all, Olympus Mons, rises to a height of 24 kilometers from its base, 3 times higher than Mount Everest, making this not just the tallest peak on Mars, but the tallest in the solar system. Such an impressive structure must have arisen through widespread eruptions of lava that poured out across the surface again and again, possibly over billions of years. Olympus Mons sits atop a giant bulge known as Tharsis that protrudes from Mars and makes it a distinctly lopsided planet. Ultimately, it led to a spectacular splitting of the planet's crust and the creation of this giant canyon, Valles Marineris. The proportions of Valles Marineris stagger the imagination. It is more than 10 times longer than Earth's Grand Canyon and 4 times as deep. Today, the best images of Mars come from the Mars Reconnaissance Orbiter, an orbiting spacecraft that carries the most powerful telescope ever sent to another world. Capable of resolving details on the surface as small as a dinner plate, it has given us an unprecedented look at Mars in all its splendor. From exquisite sand dunes to tracks left behind by Martian dust devils. But perhaps the most interesting views are the ones that suggest water once flowed on Mars. Deep inside Valles Marineris, it appears as if there were layers of sediment deposited in shallow Martian lakes, long before the giant canyon formed. Even the shape and orientation of the terrain suggests water once flowed on Mars. These hints of a watery past grow much stronger as we cast our view beyond Valles Marineris to a series of large but empty channels leading away from the Tharsis Bulge toward the low-lying regions further north. Although they dried up long ago, these valleys must have been created by vast outflows of moving water that cut across the Martian landscape, spilling out into the northern plains. In some cases, these channels measure 100 kilometers across and carve their way through thousands of kilometers of terrain. Their discovery drastically changed scientists' view of Mars. Today, Mars is far too cold and its atmosphere far too thin for liquid water to persist on the surface. Yet these channels, which bear all the marks of catastrophic flooding, suggest that Mars once had water in abundance. If so, what caused the release of this water, and where did it go? The answer to the first question probably lies with the Tharsis Bulge. It now seems likely the intense heat that led to the formation of Mars's giant volcanoes also forced the release of vast quantities of water stored in the Martian crust. At first, the water flowed underground, but then it broke out onto the surface, creating the features visible today. Across Mars, there are other signs that water may have flowed billions of years ago. Strong evidence from orbiting spacecraft now suggests much of this water lies frozen underground in the form of permafrost near the Martian poles. Certainly, the Martian polar regions are different from the rest of the planet. Not only do both the north and south poles of Mars have visible caps of frozen carbon dioxide that grow and shrink with the changing seasons, both possess a smaller underlying cap of water ice that is never warm enough to melt away. The surface at the poles also looks different. A substantial quantity of ice mixed in with the rock in these locations means cliffs and crater walls tend to slump, giving them a smooth, rounded look. One of the most exciting recent developments has been the discovery of small gullies running down the sides of craters and canyons all across Mars. They look suspiciously as though they were carved by groundwater seeping from the cliff faces and running downhill. Yet these features are so small, they must be recent. Otherwise, the steady deposit of wind-blown dust would have obscured them. Could there really be liquid water periodically bubbling to the surface on Mars? If so, the implications for life are enormous. After more than 4 decades of concentrated exploration, there's no doubt that Mars has a rich history, which certainly included liquid water and may have once included life. Furthermore, there are hints that Mars continues to be an active planet today. It is not yet a dead world, at least in the geologic sense. It is still a borderland. All of this is impetus to explore Mars further. But there are limits to what can be seen and sensed from space. To answer the question of whether Mars is a living world, we must touch, taste, and smell it. These goals can only be achieved by taking our explorations down to the very surface of Mars. Like the great voyages of discovery centuries ago, the journey to another world is fraught with danger.
Atmospheric entry on my mark.
And when it comes to landing on Mars,
5, 4, 3, 2, 1, mark.
It is always the final moments.
Phoenix now 2 minutes and 25 seconds past the entry point.
When the peril is greatest.
80 meters. 50 meters.
Come on.
Constant velocity phase detected. Altitude 40 meters. 30 meters. 27 meters. 20 meters. 50 meters. Standing by for touchdown. Touchdown signal detected. Landed it. Landing sequence initiated.
It is hard enough to design a machine that can land itself on Earth. But to do it on another planet, where humans have never set foot, where knowledge of changing conditions is scarce at best, to have no margin for error between a safe landing and total catastrophe, and to do it in a place that is so distant, even a simple call for help would take several minutes to reach Earth, that is a challenge indeed. But that is precisely what must be done to touch another world. So far, 6 landers have set down safely on Martian soil, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions were designed to discover the geologic history of Mars. but they also carry a powerful implication about the future. It's not just the ancient past we seek when we land our probes on Mars, but a new dawn in space exploration. A red dawn. In 1976, two NASA spacecraft named Viking 1 and 2 became the first to establish a beachhead on Mars. And the view was electrifying. Geologists were immediately reminded of deserts they had visited on Earth. Once the Viking landers set to work, the similarities began to fade. While the results did not completely rule out life on Mars, they suggested that any life that managed to survive here would need to be sheltered underground or in some other impossible-to-reach location. It would be more than 20 years before another successful attempt was made to land on Mars. In 1997, NASA's Mars Pathfinder landed at the mouth of the Ars Valley, a vast channel that looks like it was carved by running water. The landing site was surrounded by broken and tumbled rock. Boulders were slanted in a downstream direction, all signs of an ancient and violent flood. The star attraction of the mission was a small rover that rolled off the lander and trundled up to nearby rocks to analyze their compositions. It was a vivid demonstration of what was needed to really begin tackling the mystery of Mars: a set of wheels. In early 2004, two rovers named Spirit and Opportunity landed safely on opposite sides of Mars. Each embarked on its own motorized trek across the red planet's surface. From the start, it was obvious that the two rovers had landed in very different settings. Spirit had been sent to Gusev Crater. Evidence from orbit suggested it was an ancient lake where standing water may have left its mark in the soil chemistry. But when Spirit opened its electronic eyes, it found a barren plain littered with volcanic rock. Meanwhile, Opportunity scored an early triumph. It was sent to Meridiani Planum, where remote sensing had spotted hematite, an iron-rich mineral that on Earth is often associated with water. Meridiani turned out to be a flat, nearly featureless plain, but miraculously, Opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists would be able to sample rock on Mars in the place where it formed. What Opportunity found after wheeling up to the outcrop exceeded everyone's wildest expectations. The rock was layered and contained ample evidence that it formed in a watery environment. It also contained hematite in the form of tiny spheres, nicknamed blueberries, which grew by precipitating out of water and were later exposed as the rock weathered away. But the best was yet to come. Back on Gusev Crater, after investigating the terrain near the landing site, scientists sent Spirit rolling towards a set of distant hills, nearly 4 kilometers away. It would take 3 months to reach the hills and many more to climb them, but eventually Spirit reached the top and radioed back a sweeping panorama. In the years that followed, Spirit descended to the other side of the hills, surviving 3 Martian winters and eventually discovering home plate, the remains of a volcanic vent where hot rock once made explosive contact with water. Things were also going well at Meridiani. Once opportunity set out across the plains, it discovered an even larger rock outcrop, whose layers read like a geologic history book. The story it told was of a place that once had been wet, but with highly acidic water, while at other times there was no water there at all. After nearly 2 years more of roving, Opportunity arrived at the edge of Victoria Crater and recorded one of the most spectacular vistas in the history of Mars exploration. High overhead, the newly arrived Mars Reconnaissance Orbiter was there to record the moment from space, spying the tiny rover perched at the crater's rim. The journey of the Mars rovers has been a scientific adventure unlike any so far in our exploration of the Red Planet. Rather than showing us Mars in an isolated spot for a brief window of time, they have shown us Mars over many years and many kilometers, including places where water once flowed. Next, scientists wanted to know about the state of water on Mars today. Compared to the Mars rovers, the Phoenix lander was a modest mission, but with an ambitious goal: to become the first spacecraft to touch water on Mars. Scientists expected to find that water locked in a frozen state just below the surface of Mars's polar regions. Here, the landscape is dominated by low mounds with trough-like boundaries. These mounds are caused by the expansion of ground ice, forcing the soil upward. After a bit of digging with its robot arm, Phoenix exposed something white just centimeters below the surface. It was ice, the first direct link to a watery past on Mars. Phoenix landed in the low-lying northern plains of Mars, an area that may once have been a Martian ocean. Although Phoenix could not confirm this, it found the soil here is alkaline, similar to what might be found in seawater on Earth. What we've learned from all these missions is that Mars was a water world, and still is today, although that water is hidden from view. As for what that means for life on Mars, that's a question for future missions. But in a sense, all of these missions are already paving the way for life on Mars, human life. The landers and rovers we build could be the leading edge of a new wave of exploration that might one day take astronauts to the Red Planet. If so, the human story on Mars has already dawned.